Good morning, guys. Today is Tuesday. It's about 8:36 a.m. This is what we were going to do yesterday in class, but with the snow day, I still wanted to go over this with you guys, and hopefully you guys will take the notes. And again, all this is the topics list, everything that we've learned so far this year, and I'm going to highlight specific subtopics that I want you to pay close attention to. In addition, we'll write down some key notes about each subproperty that I think will help you out. Okay, so again, let's reiterate the exam date. That is this Thursday at 12:30. That's what time you should be here at the latest. And depending on which period you are, I believe period 3 is going to be room 201 or 254, actually 254, and then period 5 is going to be 201. Again, you guys should know that though, so double check. If you don't know, shoot me an email and I will get back to you with which one is which. All right, so unit 1, polynomial operations and patterns. There's really nothing to go over here. This was the most basic one. Everybody knew this. I would say maybe basic exponent properties is what we could go over the most here. That would be, product property, division property, power property. That's going to be page 315 in your textbook. So, you have the power property. Let's do like x to the third times x to the second is x to the fifth. Right, it's product. X to the fourth over x to the first would be x to the third, right? Subtract the exponents. X to the second raised to the fifth, you multiply the exponents to get x to the 10th. The zero power property, anything with the zero power is 1. The negative exponent property, x to the negative 2 is equal to 1 over x to the positive 2, right? And then, what's the one that we always do? We'll go into that one later. But yeah, those are the basic ones, unit 1. Nothing major with that. Unit 2 was one of those big units. It was unit 2A, 2B, and 2C. So let's go through those pieces. Polynomial long division and interpretation of having a remainder or no remainder. So essentially, this is long division and remainder theorem. All right, so this kind of goes hand in hand with remainder theorem here. So these two. You guys know polynomial long division. Let's say I gave you a quadratic like this, x cubed plus x squared plus 5. Remember, if you were using this as your divider, you need a placeholder of 0x. Right, you can't just go from x squared to 5 without accounting for that x. Remainder theorem, remember what that states. So if you were dividing by, x minus 5, you're actually going to store in when x is positive 5. If you get a remainder of anything that's not 0, and it's not a factor. Right, the only time there'll be a factor is if the remainder ends up being 0. There is no remainder. That means it's a factor. That's the remainder theorem. Factoring, GCF, D2PS, factor by grouping. We did not do sum and difference of cubes, so you can cross that one out. But all these other ones, this really went hand in hand with Unit 4, which is what we just did. That was rational expressions, getting an LCD, complex fractions. Being able to do all these factoring methods, that is going to be key. Solving quadratics by factoring, quadratic inequalities in one variable, and graphing on a number line. That will be important as well, graphing it on a number line. We saw this on the zombie midterm review game. Remember what we did? So say you got like 2 factors, or two answers of -2 and +4 or something. I don't know. You gotta test numbers that would be less than -2, so you can test -3. You could test 0, or you could test like 5. This is less than -2. That's in between -2 and 4. 5 is greater than 4. Whichever one is true. So if this ends up being true, that means that these two would be false, and that's how you shade. You would shade in between, wherever the true is. And vice versa, if it was true on the outside, then the false would be in the middle. Okay. Operations with radicals. That was very important, and we've done this quite a few times on the warm-up. What do I mean by this? Let's bring this one maybe like over here. What I mean by this is that if you have, being able to go from radical form to fractional exponent form, so x to the e with the index on the outside, this is equivalent to x to the e over I. Right? So being able to go between this and this is going to be very important, as you guys have seen in class. Never try to solve it if it looks like this, right? You want to convert it to a fractional exponent and then simplify it that way. Solving square root equations. Make sure you do your check because it looks like a check mark. Graphing quadratic functions, that's going to be your calculator. All right, don't forget like second trace 5 to do the intersect. Second trace will give you a lot of commands that you can use. Using quadratic formula, that will be given on the exam, quadratic formula. Equations of circles will not be given, and that is super important. Let's highlight this one. Equations of circles, gotta know that. Right. And that formula was x minus h to the second plus y minus k to the second is equal to r to the second, where h comma k is your center. And obviously the r is the radius. Locus definition of a parabola, that you definitely need to know as well. Seen that a lot on the midterm reviews. That was y is equal to plus or minus, depending on whether it's opening up or down, 1 over 4p x minus h to the second plus k. Always draw a sketch for those. What else do we got? Imaginary numbers. Remember your imaginary numbers. That's going to be I to the first is just I to the second is -1, I to the third is I to the fourth is +1. The discriminant would come next. That is b squared minus 4ac. Again, this doesn't tell you what the roots are, it just tells you the nature of the roots and how many there are. Okay. On to unit 3, function notation, domain and range, 1-to-1. Inverses of functions, I would say that's going to be the important one out of those first 4 subunits. Remember how to do that? You just switch x and y and then solve for y. Or if you're graphing it, say that I gave you a point of 4, 3, that would be the original. And I say graph the new inverse, you just switch the x and the y, so this would be the inverse. Okay. Key features of functions, increasing, decreasing, positive, negative, all those things. Function transformations, yep. Completing the square. Again, the whole point of completing the square, why I taught this to you, is for equations of circles. Those go hand in hand. Even and odd functions, you're going to want to test opposite inputs. Test opposite inputs. Right. If the output is the same, it's going to be even. If the output is opposite, it's going to be odd. These last 2 bullets here, those were on our Unit 3 test. It was the last lesson that we did. I believe it was around page 361 to 365, so I would check those two out in case you need them. What else? Unit 4, rational functions. That was the one that we just did before we started Unit 5. I would just look at the review packet and the notes for that. All right, knowing, when to use an LCD compared to a common denominator. All right, so definitely check those out. And we only got to forms of line and average rate of change, so you won't see this. You won't see this, and you won't see that. You will see these two, and make sure you know the slope formula. y2 minus y1 over x2 minus x1. Okay, again, this exam is going to follow the exact format of the Regents exam, and that's how it's going to look. Part 1 is 24 multiple choice, Part 2 is 13 short answer. You have to stay at least 2 hours, but you have 3. And you also will have the mathematics reference sheet on the back, or in the beginning. All right. If you guys have questions, let me know.